Today we're going to be talking about standard form, and the first thing that I would like to address is our x-intercept. The past few lessons we've been using the y-intercept to help us solve problems, and today we're going to be looking at the x-intercept. The x-intercept is where our function line crosses the x-axis. So in this graph, that coordinate point would be at -3, 0. We can see here that when we have an x-intercept, our y-coordinate is always going to be 0, just like with our y-intercept. Here, this point is at 0, 5. So whenever you have a y-intercept, the x-coordinate will always be 0. Keeping that in mind, if we have an equation here, like in example 1, that does not have a graph, we can still use that property to figure out our x and y intercepts. So if I'm looking for an x-intercept in this equation, then what I can do is instead of using this y, I can plug in a 0 for y. Just like our x-intercept in this graph is -3, 0, and we used a 0 for y, I'm going to plug that into our new equation here. So I'll write 3x plus 4, and instead of writing the y, I'm going to use the parentheses and plug a 0 into its place. And then we're just going to solve this equation like we've been doing all year long. I'm going to drop down the 3x. 4 times 0 is just 0. And we've got equals 8. Now 3x plus 0 is 3x. And in order to get x by itself, we're going to divide both sides by 3. And when we divide both sides by 3, we get x is equal to 8 over 3. So what that tells me is that on the x-axis at +8/3, we're going to have our function line cross the x-axis. So this is our x-intercept. If I want to find the y-intercept, I'm going to do the exact same thing, except this time, instead of plugging in 0 for y, I'm going to plug in 0 for x. So we're going to replace x with our parentheses and then plug in that 0 and write everything else down as we see it. 3 times 0 is 0, and everything else gets dropped down. 0 plus 4y is just 4y. So I have 4y is equal to 8. To get y by itself, we divide both sides by 4. 8 divided by 4 is 2. So this tells me that the y-intercept is 2. So on my y-axis at +2, that's where I can expect to see the function line cross. Now that is pretty simple, plugging in 0, but let's talk about an easier way to solve one of these problems. Instead of using 0 and taking up a little bit of space on our paper, we can use a shortcut method by just covering up things. If you'll notice here in the x-intercept, when we plug 0 in for y, our y term basically disappeared here. So what I'm going to do here is, instead of doing all of the work written out, I'm going to go ahead and make my y term disappear. And you guys can use your finger, I'll use my little digital pen here, and we're going to cover up the y term. So if I want to find my x-intercept in example 2, I'm going to pretend like y doesn't exist, and we're going to cover this up here. And I now have the problem 2x equals 12. And most of us here can probably do that in our head. 2x equals 12, we divide both sides by 2, so x is equal to 6. So in this problem, by using the cover-up method, I can see that x-intercept is 6. Now if I want to do the y-intercept, this time I'm going to cover up the other variable. So when we want to know y, we use our finger and cover up our x term. And you guys have probably already done this in your head as I'm writing this out, but we'll have 3y equals 12. That means that our y-intercept is 4. So that's another little easy trick that you can use to go pretty fast for these x and y-intercept problems. Let's look at our formula for today, what the lesson is named after. It's standard form. And this is your formula that you're going to need. AX plus BY equals C. Our A, B, and C represent real numbers. And the important part to remember is that you are not allowed to have any fractions or decimals. And so that's why we've got stars here beside no fractions or decimals allowed. That's very important. So if we ever see fractions, we're going to have to get rid of them, just like in example 3. I see two problems with this here. It wants us to write it in standard form. Right now it's in slope-intercept. I can see that I have a fraction here with 3/4. I can also see that x and y are not on the same sides like they are in our standard form problem, so I need to fix those things. The very first thing I'm going to do is get rid of the fractions. Anytime we have a fraction problem, we can get rid of those fractions if we multiply everything by the common denominator. And in this equation, I'm lucky because I only have one denominator, and that is 4. So we're going to multiply everything times 4. When we do that, we've got 4 times y is 4y. Over here, my 4's are going to cancel, and I'll have 3x. Over here, 2 times 4 is 8. So I've solved one problem, but I still have another because I don't have x and y on the same side. In order to move it, it would be easiest to take this x and put it over here with my y. And in order to move that x, we're going to subtract it from both sides. So I subtract 3x from both sides. And I'm going to go ahead and write this in the order. You see how the x comes first here? I want to put my x term first in my new problem. It's negative 3x, so I write that down here. 4 is positive, so I'm going to write a plus 4y beside it. And then equals 8 is the only thing on the right side, and that's exactly what I need. Now I have negative 3x plus 4y equals 8. Some people like to have your a term, in our case it's negative 3, they want that to be positive, but it really doesn't matter. You can keep it as negative or positive. Just be aware that on some tests that you see, like your grad exam, they may make 3 positive instead of negative, and all they've done is just changed all the signs behind it. But it's definitely okay to leave your a term negative. So I can stop right here. After double checking, I've got my x and y terms on the same side. There are no fractions or decimals, so we are good to go for example 3. Now before we get to example 4, I want us to look at the term Hoi Vux. It almost looks like another language, but this is an acronym to help us remember how to graph some weird stuff. So for our first term here, I've got Hoi. Hoi stands for horizontal. The O is not actually an O, it stands for 0. I guess because they look alike. Y stands for y-axis. So the term Hoi means horizontal, 0, y-axis. It's telling me that the function line is a horizontal line, which means that it has 0 slope, and it is going to go through the y-axis. Now Vux, you can probably guess just by looking at Hoi what these letters stand for. The V is vertical. The U stands for undefined. And X represents the x-axis. So V is a vertical line. That means it's an undefined slope that crosses through the x-axis. Let's look at example 4 and use this. Now anytime you have just one variable in your equation, like right now I have a y here, anytime you have one variable and not the other, it's going to be either a Hoi or a Vux graph. I have y. Now out of Hoi and Vux, Hoi is the only one that has a y in it. So that means my graph is going to be a horizontal line that has a 0 slope. So this says that y equals 3. The first thing I'm going to do is go to my y-axis, which is the vertical axis here, and I'm going to put a point at positive 3, since that was what was in the equation. Now my Hoy mnemonic says that it is supposed to be a horizontal line. So that means it's going from left to right here. So I'm going to draw the best that I can without a ruler a horizontal line through that point I just made, and I double check it. It's a horizontal line. That means it has 0 slope, like we learned in our first lesson, and it's going through the y-axis here. So I'm good to go on example 4. Now if we look at something like example 5, I can see that it says graph x equals -2. Now if I'm thinking about my Hoy and Bucks here, which one has an x in it? Obviously it's Vux right here, so I want to use the Vux mnemonic to help me graph this one. V stands for vertical. It's an undefined slope that goes through the x-axis, so that tells me I'm going to put a point on my x-axis at -2, since that's what is in the problem right here. And because V means vertical, I'm going to draw a vertical line through that point I just put on the x-axis. It's a vertical line, an undefined slope that goes through the x-axis at -2. I've done my double checking, and so I know that this graph is correct.